the physical arrangement of all the devices connected in the network is called topology. There are different topologies available in the network. Bus topology. So the name itself is saying all the systems are connected to a common bus. That is why the name bus topology is given to this. So here in this bus topology, so all the devices are being connected. This is a common bus which we are going to call as a backbone. So to this backbone, all the systems are connected using the drop cable. So this is connected to a drop cable to this, a drop cable to this, a drop cable to this. So as many systems as we want in the network, they are being connected like this. And if I want to add one more system, simply I can extend this backbone. I can extend the backbone and I can have a drop cable and I can connect another system I want. Likewise, I can extend the network. So the expansion of the network is easy in this particular case. And if you come to the functional device, so suppose if this system want to communicate with this system, so the communication will be taking place like through the drop cable to the backbone to the system. And at the same time, if this system also want to communicate, then the information sent by this system and sent by this system may be colliding at this point. So as a result, whatever information is moving in the network will be damaged. That is a disadvantage with this bus topology. So expansion will be easy. And another thing is, at this end, whatever we have, so at this particular end, so if any signal is reaching this dead end, the signal will be reflected back. That reflect signal may collide with the next signal that is coming on this direction. So as a result, the information will be lost. So because of this, whatever signal is reaching the dead end should not be reflected back. So it should be terminated at this point. That is why a terminator is to be connected at this dead end. Similarly, other end also, we should have a terminator connected so that no reflections from this end. This is how the construction of the bus topology is, but this is the easiest topology, very easy for installation and easy for the expansion of the network. So that is the bus topology. And if you see the advantages of the bus topology, low cost, because so we can avoid unnecessary additional devices like a repeater and hub. So hub is not needed in this particular case. A repeater, if you want to have the size of the network is large, then you may need a repeater. But otherwise, the repeater is not needed in this. So as a result, cost is very less. And this is as small organizations will prefer this. So more or less all the small organizations will be preferring this. So it's a familiar technology, means known by most of the people, almost all the people knows about this particular topology, whoever wants to have a network. So that is why it is. And if a particular system is failed, suppose if this system is failed, only this system will not be able to participate in the network. Only that gets affected by this system only. So rest of the network will function as usual without any problems. That is the meaning of limited failure. But the biggest disadvantage is if any cable segment, suppose if this cable segment is being failed, then entire network will be down. So troubleshooting, identifying the failure segment is difficult. That is the biggest disadvantage, because the administrator or troubleshooter may not be knowing about whether this cable segment is failed or this cable segment is failed, or this cable, or this cable, or likewise. So it is difficult to identify which cable segment is failed. So it has to be verified. Suppose to verify whether this segment is failed, so we have to remove this, because when you are using the drop cable, we have to connect a T connector. A T connector is to be connected at this point. So one end of this segment is connected to the T connector, and this segment is connected to other end of the T connector, and third end of the T connector is connected to the system. So a T connector is being used. Now, if you want to identify whether this segment is failed, so what we have to do is we have to remove this particular segment from the T connector, and a terminator is to be connected at the T connector. Then if the network is working fine, then the meaning is this particular cable segment is failed. Still the network is down, that means maybe this cable segment is okay, then maybe failure is at this point. So likewise, so we have to remove every segment and we have to verify whether the problems are there or not. So that is why troubleshooting is difficult and reconfiguration a little difficult. That means suppose I want to move this particular system from this point to maybe somewhere at this point, so it is little complex, because if I want to remove this at this point, so I have to remove this drop cable and T connector, then I have to replace these two segments as a single segment cable, then I have to add, if it is to be moved to this place, again I have to remove this the terminator, and I have to have another cable segment, then I have to have a T connector and connecting to this. So that is why the reconfiguration is little difficult, not difficult, little complex. So that is about the bus topology part.